Hello everyone, let's take a look at our next problem. Prove that 1 factorial plus 2 factorial plus 3 factorial and so on has no square values for n greater than 3. So what are my first thoughts here? My first thoughts would be, maybe something along the lines of, if I write out the prime factorization of the sum of factorials, there must be at least one prime that has an odd power or something like that. I'm not sure. And what if I write out the first few results of this thing? 1, 2 factorial is 1, so this is 3. 3 factorial is 6, gives 9. 4 factorial is 24. So I end up with 33 plus 5 factorial is 120, 153. So we do have a square here in the list, but the question is asking only for n strictly greater than 3. Okay, so I think maybe there's something here. So we have, the sum of the first 3 factorials is 9. And then it's pretty clear that every number on the list after this one is always going to be odd. And so we certainly can't have, we certainly can't ever hit an even square. And what if I look at the, so here I'm looking at n squared mod 4. What if I look mod 8? Look at the sequence of squares mod 8. So this pattern almost certainly would continue, right? 1 4 1 0, 1 4 1 0, 1 4 1 0, and so on. Now, all of these numbers are multiples of 8, no matter how many of these, each factorial, including this one and later, are going to be multiples of 8 because there's a factor of 4 here, there's a factor of 2 inside this, and that's always going to continue. And so these sums always have to be the same mod 8. But how? What if we look at the last digit? Last digit will always be a 3. from here on out, because every next factorial we add is always going to be a multiple of 10, going from here down. Okay, so let's look at n squared mod 10. I did a question similar to this earlier, which shows that, you know, asking about what are the possible values for the last digit of a perfect square. And I think this is going to give it to us. The last digit of squares has to be 1, 4, 9, 6, or 5, or 0. Like I think a 3 can never appear. 3 can never appear in the last digit of a perfect square. And so, you know, every number in this list from here downwards is going to end in a 3. And there are no perfect squares that end in a 3. So that's going to be it, right? Yeah, if I want to see all the possible last digits of perfect squares, I only need to consider the first 10 squares, because we're doing mod 10 arithmetic here. So here are the first 10 squares. None of them end in a 3. So this says that no perfect square will end in a 3. But every factorial that I add from 5 and onward, the last digit is a 0. So this digit here will never change no matter how far down I go on this list. So none of them can ever possibly be a perfect square. Yeah, a little bit of a roundabout way of getting there. And it definitely required some knowledge of previous results and previous questions I've solved. But that was a nice one. Thanks for watching.